This is a talk about multiplayer first design, right? Which is basically the idea that for years and years and years, people have been programmed to think about developing games in a certain way. You go and make the single player first, and then you make a bunch of content, and then maybe at the end, if you have time, you go and build multiplayer, and then it ends up being kind of a wreck, right? And often designers and engineers want to go ahead and make the single player content of the game first, right? It's safe, it's familiar, you can get all the stuff you want without worrying about all these caveats, right? But when it comes down to the gameplay, you end up making really huge concessions to support multiplayer if you haven't built it on a piece of technology meant to support it from the beginning, okay? But some of you may ask, what is it that happens when you do it the other way around? And that is what I'm going to be talking about a little bit today. So, a quick caveat. This session is not for first-time game developers. If you're going to make your very first game, go make a simple single-player game. Don't go jumping into the multiplayer pool, okay? And that's because the rule, your very first game shouldn't be multiplayer, still stands, right? There's so many complexities in terms of networking, traffic, gameplay, right? And the way that it slows down multiplayer testing that frankly makes it expensive and difficult to actually do multiplayer games. So go make a simple game first, but when you're ready and want to work with a team, you should consider doing multiplayer tech before anything else. Now, I'm not going to be talking about first-person shooters. Quite frankly, this genre is extremely well documented. There are many examples of it, and frankly, most first-person shooter designers, because they're building on things like Unreal that already support this stuff natively, already come from the right design mindset. They'll often do skirmishes and PvP first, okay? And so if you want to go see those talks, go see those talks. But first, most of you are probably wondering, who the hell are you? Well, I've been a gameplay designer for a very, very, very long time. Longer than some of you guys have been alive. Yay, me. I was a designer on World of Warcraft, where I did raids, dungeons, I built the pet battle system. Then I went and worked on League of Legends, where I was a combat and R&D designer at Riot Games, working on one of their secret projects I'm not allowed to talk about on camera yet. And then went on to work at both Ori and more significantly No Rest for the Wicked. I was like the third person or third designer on No Rest for the Wicked. I've also scaled an educational startup to about $100,000 in revenue a year and a whole bunch of bullshit. If you're curious about any of that, feel free to check out our website, gamedesignskills.com. We have a free Discord community where we help people play test their games online. We'd love to see all you guys in there. Okay, plugging done. Now, my journey was not a straightforward one, right? In fact, learning what it was that would make me the person that would be able to do the things I do took a long time. At first, I thought I was going to be a game designer, and I lied on the internet when I was 13 years old and said I was 24 years old to work at a French video game company. They bought it. There was no video, there's no voice back then, so I was working for 3 years as a volunteer from the age of 13 to 16 at a French video game company. This was over the internet, no one knew better. Then I got a little bored with that, and the project kind of crashed, and I was like, you know what, this project failed, I'm no good at this. If meant to be, surely I would have gotten it right. And so I went into doing Japanese to English translation. Well, turns out I went to Japan, and I didn't actually want to do that full time. So then I went to 3D modeling, and then I actually became a program manager at Microsoft. And then after that, I worked in game production at a really, really terrible studio in Aliso Viejo. But then eventually I started to meet the people and mentors that I needed in life and started rising up to the type of work I wanted to do. I ended up having lunch with a bunch of folks working on World of Warcraft, got to work on that, got to help give input on StarCraft 2, Overwatch, Hearthstone, and more. And then that bridged me into Riot Games, where I worked on League of Legends. And eventually, after Papa Tencent bought out Riot, I got to go work on Ori and No Rest for the Wicked, and eventually doing consulting for a whole bunch of little companies. Okay, but in between all of this, and unknown to most folks, between Riot and Moon, I was actually working on a cooperative side-scrolling precision action RPG. And unfortunately, that project ultimately perished because I didn't have the lessons and technology that I'm going to be talking about today. If I had it, I might have actually gotten my game playable and enjoyable. Instead, I only have pretty much nothing but this cute little animation to show for almost 3 years of work. So avoid the expensive lessons that I had to pick up and internalize what I'm about to teach you. So, number one, starting from multiplayer. Starting from multiplayer is a tale of 3 parts. The first is how technology and legacy made multiplayer first games a mistake. The second is the advantage of multiplayer first design and design patterns. And then finally, when and where this sort of approach is appropriate and how to argue for it inside your companies. All right, number 1. Oh, I just read these. Great, let's keep moving. Okay, oh, that was forward, right? No? Okay, cool. So, multiplayer first design. As a game designer building gameplay, you pretty much are focusing on 3 key things. Information, communicating the state of the game to others. Action, what the players do. And then finally, the outcomes, what happens after they've taken the actions in the world and seen the consequences of their decisions. Now, historically, multiplayer was usually a pretty big mistake. It was often built as a secondary mode. It introduced inconsistencies into a game, as the band-aids you had to do to make multiplayer work would often impact or reduce the quality of the single-player game. And often it would reduce the game quality in terms of visual effects, content, etc., to cover up the latency, right? These delays between the commands and executions on the server. And it required significant compromises as a result in the gameplay design. As a result, this also slowed down your prototyping, as you had to take longer to, hey, can we come in and jump in and play with me, right? And hey, I need to see if this is going to feel as the way I think it is. And furthermore, a lot of these things were done using replication, which meant you had really expensive bandwidth bills. Don't ask how much World of Warcraft cost to run day by day. It was a lot. Okay, but why was this? Well, in order to understand this, you need to know your history, okay? And so we're going to go into the ancient past of games and video games and talk about where it all began. And for those of you who have not always lived in the online era, there were once upon a time these games designed to be played over dial-up connections where you paid by the minute. And as a result of these games not only needing to be built to use the very minimum amount of bandwidth, right? In fact, you would actually see characters literally stream in over a physical modem. They also needed to use a minimum of processing power. And this is where the generation of games known as MUDs, multi-user dungeons, came to be. These were text only, they were singular session, you jump in, you say what's gonna happen. The game processes a few commands and it dumps you back out, usually often dead because these games were pretty brutal. All right. These games use a very straightforward and somewhat familiar technology structure. These were server authoritative, right? The server knows exactly what's going on and just tells everyone. In this case, literally with text. These games literally had no client. There was no custom work that had to be done. You just showed colored text messages and they told you literally what happened. And there was little to no permanent state. I remember more than a few times being super frustrated if my character or session was deleted if I disconnected or my mom picked up the phone in the middle of a game. Now, some of them allowed you to save, but back then storage was expensive, and so you pretty much kept nothing but maybe your character name and what level you were and what class you were, and it would regenerate your character every single time you logged off and logged back in. That's because keeping even a database of characters was considered expensive. All right. Now, while those games were great, the very next generation wanted something better. And as local area networks, right, these were physical, hardware-plugged computers attached to each other, became more affordable, people wanted to be able to play higher fidelity games. These didn't have the latency issues, right, as everyone was physically in the same room or in the same cafe, right? And so engineers began seeking ways to make higher quality experiences. And thus, inside the lockstep generation, all clients run the entire game locally. All right, players would issue orders, think Warcraft or StarCraft, and the game delays executing those orders until everyone's put their order in, right? And yes, if you guys, how many of you guys have played StarCraft at some point, or StarCraft 2? All right, about most of the room. Do you guys know that the StarCraft 2 is just or StarCraft 1 is just a really fast turn-based game? That's all it is. It just happens that whenever you issue the order, it waits 10 turns, and then it runs your command. This allows you to kind of like feel like things are happening in real time, but it also means when you're micromanaging, why you might feel like, I sent that order, I didn't execute in time, right? Because the technology is intentionally delaying you, so everyone syncs up. All right. Now, the downside of this technology is that it moves at the speed of the slowest person's connection. So if the man in the green shirt over there is going to take 30 frames longer to process commands than anyone else, everyone waits for him. But that's okay, it makes the game fair. All right. But unfortunately, these type of problems still happen. In the pre-BattleNet era, a lot of games were still on LAN, which meant lag was microscopic. But if someone went out of sync, something we'll talk about another time, or you can go to the talk of Guy Davidson. He's actually talking about floating point precision. If the game wasn't sophisticated enough or a player just bailed on the game, it would basically say there's a sync error or a disconnection and everyone freezes up and locks up or maybe loses the game completely. All right. First off, these type of games are incredibly hard to stop, save, and resume outside of single player. In fact, one player could even theoretically manipulate the save, load it up, and everyone rejoins and finds, wait a minute, why do you have 1,000 workers? All right. And the architecture in these sorts of games relies on everyone's gameplay logic to play out the same way. Hence, it's called the term lockstep simulation. Uses command networking, as I talked about, but at the end of the day, the clients are all authoritative. Everyone can say what's happening. If someone says, I did 3 damage, and someone says, I did 2 damage, the game goes, wait a second, and freezes everybody and checks all the rules. Okay. All right. Now, and again, it's all because of floating point determinism, which is a awful, awful problem that I don't want to talk about, but there's a talk actually later today by Guy Davidson. Check that out. But at the heart of everything is the concept of drift. Due to small differences between frames, calculations, the operations that are done because the guy in the black shirt's computer and the guy in the red jacket's computers are slightly different in physical hardware, you get drift. Things start to go further and further and further apart. Okay. Now, the next generation of games, right, came with the explosion of the broadband internet era. Suddenly, you're connected to thousands, if not hundreds of people, right? And with the explosion of ISPs and everyone being online, this opened up the fantasy of being connected to many people at the exact same time. This was the era of EverQuest, Ultima, and eventually World of Warcraft. And these were inspired by nothing less than those MUDs, those very same text adventures that we just showed you a minute ago. And so the server technology and experience was built upon that type of architecture, that same sort of reflection. And so it heavily limited the gameplay by the expense of running every single person's actions on the server. Now, however, this meant that clients could show the world as beautifully as possible, while the server code has the minimum amount of information, just where are you standing, what button are you pushing, who are you targeting, right? And so that information, your position, your hit points, your status effects, what creatures are around you, were all sent up and down the network through a stream known as replication. Okay. So again, it's not surprising that MMOs were very similar to MUDs. They just had a prettier way of looking at the world. Okay. Now, in these games, the server was the ultimate authority on what happened, which again does eliminate cheating for the most part. That is a very significant advantage of having. Oh, this is not a laser pointer. Okay. All right. Anyways, now. However, some elements, how many of you ever saw the cheaters who climbed to the top of Mount Hyjal in World of Warcraft? Heard about this? Okay. How many of you were the hackers climbing to the top of Mount Hyjal? Oh, none of you. Okay, good. Well, we'll catch you next time. Anyways, this was because positioning, moving, gravity, all of this was only on the client. The server just said, oh, you didn't move too far away from where you were before? Probably legal. Just keep doing what you're doing. However, whenever it did catch someone a little too far away or it took too long to process the events and actions on the gameplay, you would experience what is known as rubber banding. This is where wherever you're standing is ignored and said, no, get back over here. And you would run and then, right? How many of you have felt rubber banding in a video game? Okay, it sucks, right? You're like, what is wrong with this game, right? And these moments are just extremely frustrating to players, but are a necessary piece and a price of using what is known as replication technology. There's just no way to avoid this. Eventually, under some conditions and sometimes, where the client says it is and where the server says you are going to mismatch. And so the client has to listen and has to happen quickly to avoid you drifting further and further from where you should be. As a result, even Throne and Liberty, this is an MMO that came out, I think, 7 days ago, all right? And it's done by the wildly experienced NCSoft, suffers from, frankly, a very disconnected game feel. Have any of you seen the talk by the God of War designers as they talk about all the elements that go into making the Leviathan axe feel crisp and crunchy and strong, right? It's one of the best talks out there. And this sort of game feel can't be done when you do it over the network with replication, because this sort of experience is going to be constantly rewound or slightly off or slightly adjusted, or the timing won't line up exactly right because of the technology they used, right? These MMO games, by their nature, rapidly reach a cap of how physical, reactive, and satisfying the gameplay you can design for them will be, due to the limitations of the speed of light between the player and the server. Right now, we cannot make light move any faster than it gets to the server and back, right? All right. So it's no surprise then that in response to decades of playing MMOs, gameplay engineers would start looking for ways to find a way to make games feel better, richer, and more effective. And actually, 19 years ago, with the advent of GGPO, and other programs, and more recently, 5 years ago, Photon's quantum package, did the general understanding of technology known as deterministic rollback come to be. Again, this is a very technical talk. Apologies if you're lost, just raise your hand. I will try to simplify it down. Came out. And with this technology that still a lot of developers and upcoming designers don't really know about and understand, game developers have unlocked the ability to have faster, visceral, more physical gameplay while still having competitive quality games online without losing the game feel. This was used in Street Fighter. It's used to a certain degree in League of Legends, which actually started out with replication and then came back around to this technology after years when they rewrote the entire engine in an incredibly expensive, incredibly exhausting process known as cuts. Clean up that shit. Okay, and there's some limits, right? There are things you need to keep in mind. You are never going to get more than 100 players using this technology very effectively. Ideally, you have it under 16 players, live and in the same space. But when you do this, you can get all the quality of single-player gameplay feel as a game designer. And things like replaying, rejoining, and so on are innately supported in the game experience. And the most interesting thing about this technology is that lag is felt by the lagging player and not by everyone else. So if you actually have a bad internet connection, you're going to have a harder time keeping up with the other people. We're going to feel a little bit more responsive, get their information faster. But everyone else sees the game play out in a consistent and reasonable way. So how is this structured? At the heart of this technology is actually an improved version of the same technology that supported the lockstep generation of games, StarCraft and so on, which is that every single person has a complete version of the game running locally on their computer. The only difference is that the only thing you send across the network is known as the input replication. So if you're pressing the A button and you press it at a certain timestamp, I find here that you press that button at that timestamp. And the gameplay can actually rewind to the state of the game when you push that button. So if you and I both, let's say you throw out a punch and I do nothing, I would take damage, right? But if I press block, you're going to push the button and you're not going to see me blocking. But I did push it at the exact same time, expecting that this was going to play out. All right. Anyways, inputs and commands are actually signed with the index of the frame and where they happen. And as a result, you only have to reconcile a small amount of differences based upon the visual state drift of the gameplay, right? All right, let me just do a quick check in the room. Who have I lost already? Are you guys following? Okay, got it. All right, we got the super technical guy in the back is following. Noted. Appreciate you. Okay, let me try to simplify this down a little bit then. Okay. The end result is this really cool video. Let me see if I can actually go here. The result is that you can have multiplayer gameplay that is fast, frenetic, accurate, and has a sense of physicality. If you look at the animations here, you can see each of these players actually are struck by various visual effects. They're pushed back, so on.
Hey, I'm Eric from
would you
Double
please
Stallion
mute
Games.
the audio,
This
please?
is Surfpunk.
Cut the audio, please.
PvE co-op extraction ARPG.
Cut the audio,
set.
please. Thank you. Thank you. Anyways, now this isn't a game that I worked on, but it's a great example that came out recently. The issue is that when you wait for a server to tell you, did I hit someone? Did I strike someone? Did I physically move from place to place? You can't have the level of physicality and speed that you're seeing in a game like this, right? Okay, so, all right. But you might be wondering, okay, so great, this thing seems awesome. I'm sure you use it in different places, but you said that League launched and League was a very successful game. Why would they change out their technology base halfway through? Well, I'm going to show you probably one of the most amusing bugs in League of Legends. Now, League of Legends was initially built using state replication. It would just echo down to the game, hey, this is happening, hey, this is happening, and so on. And unfortunately, this caused endless problems for the developers as the visuals and gameplay fell out of sync. And this video from 2014, the 2014 engine, shows perhaps one of the clearest examples where the character position, missiles, and gameplay are out of sync. The visuals were entirely client-side, so if you watch really carefully here, you see that Ezreal gets knocked up in the air. The missile flies way over the head of the character, but he still dies. That's because it was rendered in a 3D engine, but the gameplay was 2D. And this is just one of many, many bugs. Sometimes you would shoot in different directions than you were actually facing. And this was due to the limitations of replication, and frankly, all the attempts to band-aid the issue with client-side improvements just hid these problems. So let's talk a little bit about how technology has warped design over the years and changed how we think about gameplay. Now, MUDs were very straightforward. Do whatever you want. The downsides are it's slow and only text. But there was no limit on creativity. You could do whatever you wanted. You just had to describe the words, and the player would imagine everything in their own head. Whereas MMOs were built around having high volumes of players with relatively weak server architecture. We didn't have clouds back then when we made World of Warcraft or Ultima or EverQuest. As a result, the interactions between the players and each other and even the enemies was very simple. In fact, I often describe these games as sack of hit point games. There's a big boss. Your job is to burn him down. Your hit point's going to go down. Hope that healer pushes your bar back up, right? And so the experience is actually pretty shallow. And this, by the way, is where the Holy Trinity came to be. Everyone know the Holy Trinity? Tank, healer, DPS? Okay, great. Well, guess what? This is just nothing more than a fancy version of the game of tug of war. The tug of war is between the monster and its damage, how hard it's pulling you, and your tank's hit points, and how long fast your healers can heal it up, which is them pushing back on you, while your DPS push the enemy. It is just nothing more than a simplified version of tug of war. As a result, things like positioning, actions, timing are all really sloppy. And aside from how fast can I push the buttons and can I minimize every single delay between my actions, there isn't that much optimization, right? Again, I'm sure someone's like, but I did that really cool spreadsheety thing. That's nice. But we're talking about gameplay and gameplay feel here. Okay, these games are simple because the technology could only support so much stuff happening on the server at a time. And you can see how these limitations of the technology shaped the moment-to-moment gameplay design. You have tab targeting, locked on targets, because it says, hey, I don't really care where this thing is standing. My fireball spell needs to hit where that thing is standing. And so things like the position of enemies, especially in PvP, were often wrong. If you threw an AoE down, it had to be a really big AoE. You couldn't do precision sweeps and arcs and so on. Again, let's take a look at the RTS generation. Now, the lockstep generation made it possible to handle hundreds, if not thousands, of units on screen. And the gameplay, as a result, became really about giving broad, rough commands and watching them play out in front of you. Basic commands like running, patrolling, etc. You could move the camera really fast, something you couldn't do in server-based games, because in those server-based games, it had to say, oh, you moved over here, let me show you the 300 units and exactly all their stats and send them all down over the network. Well, but in these games, you had the full state of the game. All you do is like, oh, I'll unhide these enemies from behind the fog of war, right? But this came with some downsides. Sure, the health, the stats, the experiences, they're all great, but then you could hack the game by turning off the fog of war. The commands were delayed, and again, but the best thing is you threw a nuke down, it hit everyone in the exact same area every time. So precision gameplay began to rise, and thus the beginning of Korean esports. In fact, if you think about games as an evolutionary series of steps, you can sort of see that MOBAs kind of bridge the gap in between these two, sort of a transitional phase into the next generation of multiplayer, right? The game actually itself begins with a laning phase, and it's, again, a tug of war, the same tank, healer, DPS structure, but it's between the towers and the minions and the damage that the minions do against each other. But as the game begins to degrade and the towers fall and suddenly you go into the team fight phase, all of a sudden this looks a lot more like American football, right? I'm not a big football player, but you notice that all of a sudden there's positioning and strategy and synchronization and who does this attack and does a move go in and then lock you down and is there a massive AoE, right? Okay. And this started to erode that sense that, hey, maybe multiplayer games have to either be full-on Twitch or full-on RPGs with delays, right? Okay, now, I'm going to skip over this a little bit, but moving from replication to determinism meant that we fixed things, like the spells and visuals were no longer owned by the client, but were instead synchronized entities that were indeed rendered by the client, but their position was going to be the same, their aim, their direction, and so on was going to be consistent, and as a result, you didn't see as much positional drift. You could dance back and forth, and then the rise of people like Faker was very much a side effect of suddenly the technology being capable of representing the commands, inputs, and actions that he did, all of a sudden being reflected in the gameplay that everyone else in the server or in the session experienced. And so we come now to precision action RPGs. These are games like No Rest for the Wicked. These are games like Dark Souls, right? These games are actually defined by clear, strong, and consistent gameplay, right? This is all about game feel. Does your animation, do your visuals, do the reactions of the enemies feel appropriate and significant? And best of all, these experiences don't penalize laggy players, which as a result allows for very strong reactive gameplay. Now, for those of you not familiar with these concepts, right, or haven't played No Rest for the Wicked, I've drawn this very lovely, cute little diagram here. Oh, that's a terrifying skull. Right, in these games, enemies throw out attacks and zones of damage, and you can dodge roll out of the way. You can fight with others and collaborate to poise break enemies, right? Stunning them, disrupting them, and so on. Okay, and yes, I did take the time to put a hat on that skeleton over there. It apparently didn't keep it on properly. Anyways, the important parts to these games is that anticipation needs to be communicated, right? You need to see that the attack is coming so you can pull up your shield and block the attack. And then I'm not going to dodge roll because damn if I don't have the healthcare and out here for that. But this means that multiplayer agency then needs to reflect that same experience, dodging and blocking and parrying and changing weapons and sidestepping, right? And as a result, the reliability of your strikes, their spacing, size, and timing have to be perfect. But the outcome is a sense of unparalleled richness, of quality of the gameplay that you simply cannot have achieved in the previous generation of games, right? And for this type of technology to work, especially online, you need to have this type of technology, right? But the result is your visuals are perfect. You don't have positional drift. There's sometimes a little bit, but you resolve client side for allies standing around. But the best of all, your network traffic is cheap, which means it can be fast, which means it can work with mobile, and it can work with consoles if you wanted to. So we're about halfway through the talk, and I've only got 15 minutes. So I'm going to go speedy here. So how does this change the present? Well, for this type of gameplay, you need to understand that all of a sudden, all of the problems that we had when developing multiplayer games have now been dissolved. Now, we don't have to treat multiplayer as a different mode with different rules. Multiplayer can use the same single-player code. Your quality of visuals, the game feel, is identical because it's simulating the gameplay using the same logic. This means that I can playtest locally immediately and know that the consistency of the experience I develop, the reactive tools, the spells, the actions, can be built with the same technology and rely and trust in the quality of that gameplay, that it can be rich, responsive, and reactive. And this unlocks the accessibility of multiplayer-first design to people like everyone in this room. You no longer need to sit and wonder, like, hey, do I need to have a $500,000 team in order to make multiplayer work? No, you can use these technologies and get on board and launch them with, frankly, almost turnkey experience. All right, cool. So, that was a lot of history. All right, so now we've gotten past the technical hurdles that made this type of design risky. What are the things and the advantages? Why would you want to do this, right? I spent a whole lot of time talking about how it's better, but why? Well, when we were first planning out the combat for No Rest for the Wicked, and we moved on from the quick and dirty prototype that Robin Hubb had built with the creative director, my first direction to the team was to build PvP before fleshing out PvE. And this is actually really important. If you do it this way, you can build enemy AI that works around the timings, the reactions, and the systems of PvP. And the visual communication, the telegraphs, all the work that you put into building that content just works, right? Now, there's a lot of easy mistakes that could be made by building your game for PvE, right? In fact, if you build PvE first, you will often sabotage yourself by having things like near instantaneous attacks or feedback, right? Things like Hollow Knight, if you played Hollow Knight, right? Sure, it feels really cool to push the button and instantly see the sword sweep, but as it turns out, that doesn't give a window to cover up the multiplayer latency and the reconciliation, the alignment between the players on the different servers. And so these games will often have a lot of rubber banding. But most importantly, it means that you can build your reactions into the gameplay. In PvP, and this is a concept that transcends genre, your defensive moves and reactions are the genre-defining part of your gameplay. In MMOs, you basically get move out of the way, interrupting spell bars and other latency sensitive status effects, dispels, and so on, right? Even Throne and Liberty, which just came out, still sticks to this same tried and true and very dated casting interrupts on specific attacks, right? But if you look at things like League of Legends, now you can have things like twitchy summoner spells and highly reactive defensive abilities, shields and cleanses, and so on. In first-person shooters, things like taking cover, cooking grenades, and smoke effects, right, are effectively your equivalent of defensive gameplay. And as a result, the entire game is shaped around how you respond to the challenges your opponents create for you. And so in the highly sensitive reactive mechanics in ARPGs, these are block, dodge roll, and parry, right? Which is why developing for technology that makes multiplayer latency not an issue is essential, all right? And so we actually attacked No Rest for the Wicked with a fairly straightforward plan. Fortunately, we had actually worked with Tim and some of the others at the Photon Quantum team, and we had an amazing set of technology. So we actually had playable PvP in our game that was as interactive and rich as Dark Souls within weeks of having built the content in single player. It was probably more time just building the UI to connect everyone together than it was to actually build out the gameplay. And so I directed the team to do this in 3 stages. Number 1, we started out with a combat gymnasium, a basically very empty, very open environment where you built a target dummy and you just focused on getting the players' strikes and animations to feel right. The second stage was a PvP arena, where now we focused on is the timing, the telegraphs, the visuals, are they unique and communicating the state of the spells and attacks that are coming in on you? And then do the responses to that gameplay work? Can you dodge, block, parry, etc.? And does it make sense? All right. And then afterwards, once we had those things working and we knew that the PvP not only worked, but was interesting, engaging. In fact, we ran numerous tournaments internally with about 7 or 8 different weapons, including mixing ranged weapons, bows, spells, and magic with the melee combat, that it suddenly started to come together. And we realized, hey, let's go now build enemies. Then we went and built bosses and expensive animation and AI logic and complex interactive destructive arenas. And as a result, the most polish goes onto the parts that are the player touch points, those elements of the game where the players are interacting daily, weekly, and so on. And this is because the core gameplay design is absolutely essential to nail if you want to have a goal of high agency gameplay, right? Now, in the early stages of No Rest PvP and PvE, we had 2 major categories of player threats, and things have drifted a bit since then, but these were sweeps and thrusts. These were the offensive verbs that enemies could throw out at you. And then we introduced the core defensive options from Elden Ring and Dark Souls, right? Block and dodge. And using these skills introduced a lot of decision-making and physical execution to the game, but it just felt like there was something slightly missing, right? Playing with just dodge rolls and attacks actually led to a game where you disengaged and often went back to neutral, and it felt like you'd go in and hit, and then you'd walk away. And you'd go in and hit, and you'd walk away. And we were missing that sense of tension and back and forth gameplay that things like Street Fighter and other competitive games brought natively in their experiences. So we actually discovered there was a lot of potential design space for a third concept known as the quick step. Now, quick steps were not exactly new to precision RPGs, but previously they were just really fast, kind of overpowered dodges with long invulnerability windows in Dark Souls. But we realized that with our unique camera angle, right, we were looking at the game from top down. This is an actual diagram that I made to explain this concept to Joe Sopko, who is the other combat designer with me. And the idea was that, hey, can we make it so that the same set of decisions can have differing consequences based on the nature of the enemy action, right? If they throw a thrust out at you and you quick step backwards, do you still get hit? But if you sidestep and they're sweeping, then you get hit, right? But if they're thrusting and you sidestep, you dodge, and if they're sweeping and you backstep, you dodge, right? It turned out this worked really, really well, all right? As a result, we were able to dramatically vary the different outcomes of different player moves, creating a really rich and varied map of the different decisions for the players, right? I'm not going to go into this whole thing. I have an entire course on analyzing combat gameplay, but you can see that we were able to think about how each different category of attack had a different set of interplay with the different player defensive options. What happens if they sweep when an enemy thrusts? So, well, the thruster is going to win because they're faster. If you block, well, okay, that's going to work pretty consistently, but it's eat a bunch of stamina. If you dodge, it's guaranteed going to work. You have to get the timing right. And if you parry, you're going to get a great result, but you have to get it just right. And as a result, we actually mapped out and revealed a number of core problems that we didn't realize were intrinsic to the game balance with all of these options thrown together, right? Block breakers built Breep block, that's great, but wait a minute. All of a sudden, certain abilities and skills trumped everything else all of the time consistently. So we actually were able to realize that, hey, we had some very simple rock, paper, scissors issues. And without going into all the details of this, we realized that by creating sequences, so quick stepping beats thrusting, and sweeps beat thrusts, and quick steps are beaten by sweeps, we were able to realize that actually by creating a sequence of rock, paper, scissors actions, both in the defensive actions and a series of offensive abilities and skills and so on, we could create really rich, varied, and intrinsically interesting PvP. And so we probably saved ourselves from having to redo almost a year's worth of content by discovering these problems early on. We didn't have to spend all of our time rebuilding content because what worked in PvP, we knew could still work in PvE. So when is the right time to go to your team and be like, hey, we should probably be approaching our PvP design before we do our PvE design? Well, first off, if you want to set up your game for success, you need to know that you have a really strong decoupling of state, character, controllers, and your tech designers need to have a strong understanding of static, dynamic, and ephemeral state, right? And this type of technology is best for games with strong animation, visuals, and game feel components, and focus on relatively small numbers of players in a single session. All right, so in order to achieve success here, to build these types of games, you need to avoid what I call the Muppet problem. Does anyone know what the Muppet problem of Unity developers is? All right, okay, we'll get to this in just a second. Well, best off, you start off with some sort of technology, check out Photon Quantum or any of the other new services out there that offer deterministic rollback. And try to avoid the not made here psychological trap. This is a trap companies have said, we didn't write this technology, we're not going to use it. We can do this cheaper back home, right? Well, unfortunately, when you do that, it doesn't go so well. All right, so this is probably going to be a little technical. How many tech designers do we have in the room? Okay, we got 2. Okay, you guys will get this. All right. All right, so when most people go about building their very first game, they tend to build them like Muppets. This is code that combines the character, the controller, and the input all together. And some people may look at the technology built for other games, and be like, oh, that's a very nice puppet, but look how pretty my Muppet is, right? But in truth, it really looks something more like this, right? You've kind of just jammed everything into one class, stuck your hand up the back, and you're directly running what's happening. This type of data architecture, this type of structure, this type of gameplay design is terrible for networking, right? On the positive side, it's super easy to build, but the downside is it will devastatingly kill you when you're trying to make an input synced architecture. This is the thing, by the way, that actually killed me in my first game back in 2016, 2017, right? All right. And in case you aren't as technical, a puppet looks something like this. It takes the input processing. Hey, did someone press the A button? It tells the controller, go figure out what's going to happen, and then it tells your character puppet, that model, that animation, what to do inside the game. It is not a class like this one on the right, where you have a single thing that's your character controller. It says, hey, if you press the A button and you're on the ground, do the jump, and it runs everything out of one class. That kind of technology, that's totally fine for a single player game. It will get you murdered in multiplayer online games, right? And so the next thing to understand is the difference between the different layers of data. How much time do I have here? I'm seeing 4 minutes. Is that correct? All right. All right. So this is the static data is the stuff that's generated from the editor. For example, if you build an animation and you kind of do right, great, cool. What did I do? Well, I did as an animation, but I also translated a certain amount of distance. Now, some of the people who worked on No Rest or other action games will note that typically what you have to do is pull that information out of the animation. You need to say, okay, I start over here, I have a little acceleration, then I have a slowdown, right? And you have a motion curve. Well, that information you extract out into static data, you put it into the gameplay simulation, and you don't show it in the animation. The animation itself then just plays and is synchronized with the root motion. Persistent data, this is the stuff that everyone who works with MMOs knows about, right? You log out, you have a character with some gear, you've got different abilities, you've got a certain amount of level up progression, and then you've got your dynamics information. This is stuff that when you log out, no one cares about anymore. What was your hit points? What combat state were you in? What animation were you playing, right? These are things that are really important during the gameplay, but you can just kind of forget about them. And the final set of the 4-layer state cake is ephemeral data. This is stuff like VFX and UI toasts and things like that. You don't really care about where the damage number goes once it's sent to the client. Just kind of play it, everyone sees it, and you move on. All right. So with these considerations resolved, this technology actually ends up completely eliminating the really exhausting, error-prone, and frustrating delays that are caused by waiting for teams to write bespoke netcode. All right, programmers in the room, how many of you had to write bespoke netcode before for a game? Oh, we don't have anyone in here who's done that. Whew, all right. Well, great. Okay, all right, I spent a whole lot of time talking about this technology, when you want to go ahead and build out game feel with these sort of things. Let me go ahead and tell you when you shouldn't do this, because to understand this, you need to understand when you shouldn't be going down a route as well. Now, here are the times you shouldn't be using rollback type technology. If you're going with a game that has massive scale, over 100 players, it's just not efficient and effective because you're going to need to have everyone in a synchronized state. And as a result, if you have 100 people, 1,000 people moving around a room, it's just not going to hold up. You're going to have too much rollback, and replication actually is better in that solution. If you're building a single-player game, then you can honestly get away with whatever you want, as long as the gameplay works. If you have no intention or desire to make multiplayer, don't bother with this complicated separation of data, state, and experience. If the gameplay interactions between players are pretty much trivial, if you just collect resources or are going to basically have like, hey, I'm going to trade an item with you, but for the most part, we're playing our own separate game. You don't need this, right? Or if you have a game where server-only information is incredibly important, right? Things like, hey, we're going to go hide a bunch of stuff in the world and no one can know where these things are hidden unless they walk there and pick them up, right? Hidden treasures in World of Warcraft and so on, right? These things can be immediately data mined and discovered if they're embedded in the client code and the data information, right? Okay. Next, there are social risks, right? Here are the really main obstacles to have and go into a team like, let's go build multiplayer first. Number one, if the leadership of your team doesn't understand what the benefits of doing this first are, right? Or they don't value multiplayer for the project you're working on. The second one is not made here syndrome. They're like, well, why should we trust technology that we didn't write ourselves? Again, if you're a super experienced team and you have billions of dollars to go and build great engines and reuse things, great. You guys go live in your own world. Most of us in here are, getting by the very bootstraps of whatever money we can scrape together from our previous projects to keep going. Use technology that's going to save you money by spending money in the right time and place, right? And so the third social risk is the tech team has something they're really attached to, some homebrew solution from a previous project, and they want to use it again, even if it doesn't make sense for the gameplay. So what do you do when, oh, there we go, cool. So what do you do when these kind of questions come up? Well, hey, we could make this at home much cheaper. Well, realize that bespoke, that's custom-made solutions, are always going to cost you 100 times as much as you have to rediscover every problem that someone else has already built. And frankly, you'll be better equipped to build your own version after having worked with someone else's technology first. All right. The next one, I already have an MMO-style engine. Let's just use that and make it look real nice. Well, the result is that you're going to be severely limiting the quality bar of your gameplay and game feel if you're waiting for what I told you before, the information seen on the client, the action performed, and then the outcome to be decided by a remote server. If all of that can be decided locally, you can make very physical, very visceral gameplay feel, right? And but more importantly, technology should always be serving the product vision, right? Not constrain it out the gate. Unless your vision is 1,000 players together wandering around a city, playing emojis at each other, don't use dated MMO technologies. All right. I don't understand how this works or how this is better. This one is probably the most common, the most reasonable question. Frankly, this sort of technology, deterministic rollback, and all of the ways that enables you to build really strong single-player, local content, and have it work consistently in multiplayer, hasn't been really widely available before about 5 years ago. Now, GGPO has been around for 20 years, but you had to be a really significant expert in understanding networking and how it plugged into all of this to utilize it. And frankly, this sort of understanding does require upfront investment, which can make people hesitate to go into places they haven't worked or developed before. But the end result is that the amount of time it takes to really understand the separation of code, data, and game design ends up resulting in better architectures that actually reflect the nature of the games that you're building. The next one is just that I just don't get it. Let's just try what we have, right? This one is when people or your teams are just sort of like resigned to working in the state that they're in. And if that's the case, and they're like, listen, you're making all of these arguments, you're probably right, but I don't get it, or I don't have the time, you need to be really, really clear with them about the limitations of the decision that they're making. You're not going to have a God of War feeling game if you're using MMO technologies. Is that what you want? Are you okay with that? Are you at peace with that? Are you aware that the choice to not take the time to understand this sort of change of paradigm, this way of thinking, is going to mean that in 5 years your game is dated? Are you okay with that? If they say yes, well, there's nothing you can do about that. But as a designer, whatever else happens, remember that you want to prioritize exploring for the game's fun first, right? This means building out the player actions, the problems, and the solutions in the toolkit that the players will get to engage with the gameplay with. So try to save things like exploring really expensive systems and content for later on, and hold off on expensive presentation work, fancy visuals, and things that eviscerate the head of the monster and send it flying. Save that stuff until like far later, after you've gotten through your prototyping phase, after you've gotten through the point where the gameplay actions, the reactions, the mechanics themselves already feel good and interesting. Because when you do that work, it often hides these root issues, these fundamental problems that are brought in by technology. So don't cover up the mistakes to such a degree that you set them up for failure down the road. All right, cool. Well, that's the end of this talk. I'll go into some Q&A in just a second here. But if this was interesting and you want to learn more, this was a very, very technical talk. Most of the stuff I teach about is more gameplay and game design stuff. If you want to hear about any of that, I've got about 100 free articles here on game design on gamedesignskills.com. You guys can go in, check them out, everything from combat design to game mechanics to, I think we're actually working on one about boss fights that just came out by Sarah Costa.